octagons, can be triangles. They can also be quadrilaterals. These are things with 4 sides. Okay. Now, quadrilaterals can be broken up into different types. And I'm going to come over here and look at different types first. One type is the trapezoid. Okay? Trapezoids are going to have at least one set of parallel sides. Now you'll notice these 2 sides right here, AD and BC, are not parallel, but these 2 sides that are in blue are parallel. At least one pair has to be parallel for it to be a trapezoid. So when we look at quadrilaterals, we can have trapezoids where we have one side being parallel. The other direction that we could go is what is considered a kite. Here's a kite. Okay? You'll notice these 2 sides are not necessarily parallel. These 2 sides are not parallel. The 2 adjacent sides, whenever I talk about adjacent, they're the 2 sides that are right next to each other. These 2 sides and these 2 sides are congruent to each other for a kite. So we have 2 sets of adjacent sides that are congruent. So like a trapezoid, these 2 adjacent sides are not congruent, so it cannot be a kite. But here we have a kite. So a trapezoid cannot be a kite, and a kite cannot be a trapezoid. So we have 2 separate directions going here. With that, with a trapezoid, we have isosceles trapezoids, where exactly one pair of congruent sides. So where we have the isosceles trapezoid, only one pair of the sides are congruent. And that's where, like, you'll notice that AB and DA, let's see here, AB and DA are the same. Oh, I'm sorry. I want to look at this one. Not the kite. I want to look at the trapezoid. So AD and BC. So BC and DA are the same length. So we have exactly one pair of sides being the same. That's an isosceles trapezoid. So under the trapezoids, we can have an isosceles trapezoid. Oops. And I'm running out of room, so I'm going to actually erase that so that I can write that a little bit better. Let's see here. Isosceles trapezoid. Or, if it's not isosceles, then it's going to be a parallelogram. So, when we come over here, the parallelogram is both sides. That's a trapezoid, but whenever we look at these, here's a parallelogram, because the opposite sides are congruent. It's still a trapezoid because the opposite sides are parallel. Now both opposite sides are parallel. Here, this trapezoid, if you notice, these two sides are not parallel. These two sides are parallel, but these two are not. Here, both sets of sides are parallel, so we have a parallelogram. Now, if the parallelogram, like this, has right angles, so I'm going to move this up. So we have here, and I'm going to get rid of this. If we change this to a right angle one, then it becomes a rectangle. So we have trapezoid, we have parallelogram, we have a rectangle. So we can have a rectangle. Now, a rectangle is also an isosceles trapezoid. Because remember that an isosceles trapezoid had two sides that were the same length, and one pair of opposite sides that were parallel. Well, let's look at this rectangle. Here's one set of opposite sides that are parallel, and, well, here's two sides that are the same length. So that makes it an isosceles trapezoid. But now, because these sides are both parallel, and these sides are parallel, it's a parallelogram, and that it has all right angles, it's a rectangle. So a rectangle is both a parallelogram and an isosceles triangle. Not a triangle, I'm sorry, isosceles trapezoid. A parallelogram that two adjacent sides are congruent. So basically meaning all adjacent sides are congruent. Would be considered a rhombus. So we have all adjacent sides are congruent. So that's a rhombus. But notice, adjacent sides are congruent. The other adjacent sides are congruent. That's also a kite. So a parallelogram in which all adjacent sides are congruent is considered a rhombus, but a kite can also be, well, a rhombus is also a kite. So remember, we're going upward, like this. And then things that have equal sides and all right angles is going to be a square. So a square is a rectangle, but it's also a rhombus. So if you're a square, you are a rhombus, you're a rectangle, therefore you're a parallelogram, you're an isosceles trapezoid, so you're a trapezoid, you're also a kite, and you're a quadrilateral. So a square is actually all of these. Just like an equilateral triangle is an isosceles triangle, and a triangle, and a polygon. If you are in the hierarchy, you are not the items below. You can only be the items above. Okay? So let's look at some true-false statements and see if we can answer these. An equilateral triangle, so an equilateral triangle is an isosceles triangle. So since the equilateral triangle is underneath isosceles triangle, that is true. Because remember, anything underneath, if this is underneath it, then yes, that is true. A square is a rectangle. That is true. A rectangle is automatically a square. No, not all rectangles are squares. So that's going to be false. A square is a regular quadrilateral. Well, a square is a quadrilateral, and a regular polygon, remember a regular polygon has all interior angles being the exact same, so yes, that's true. A square is a rhombus with a right angle. Is a square underneath the rhombus? Yes. Does a square have a right angle? Yes. So that's true. Some isosceles trapezoids are kites. So let's look at where isosceles trapezoids and kites. Are those anywhere underneath each other? No. So that is completely false. If you are a trapezoid, you are not a kite. If you're a kite, you're not a trapezoid. If a kite has a right angle, then it must be a square. Okay, so a kite. If it has a right angle, let's go back over here. So this is a kite, and if I make one of these angles to be a right angle, oh, there's my right angle, but then this and this have to be the same length, so DA and CD have to be the same length. Okay. Oh, still need to get that to be a right angle. There we go. Let's see here. AB and BC have to be the same length. So AB and BC have to be the same length. Let's see here. It's hard to get those to be the same length. Trying to get them to be the same length. And the only way that I can get them to be the same length is going to be actually let's see here, right there. Okay. So it could possibly not be actually a square. Because notice I have these two sides being the same length, these two sides being the same length. These two sides are not the same these two sides are not right angles. So that is actually a false statement. A kite has a right angle, then it must be a square. That is a false statement, because we just proved that it's false. The base angles in an isosceles triangle are congruent. That is going to be true. And a parallelogram is a square. That is false, because not all parallelograms are squares. They can be rectangles.